Hello friends, welcome back to Susan and John MathTube. In this video, we are going to learn about how to determine whether a set of vectors are linearly connected or not. Connected in the sense, are they dependent or independent? Okay, now look at this. If a few vectors, let's say x1, x2, x3, etc., are connected, are dependent, then there will be a relation between them. Anyway, I am not interested in a quadratic relation or a higher order degree relation, but I am talking about linear relation. And the best method to determine this is, we assume there is a connection in the form lambda 1 x1 plus lambda 2 x2 plus lambda 3 x3 plus dot 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 plus lambda n xn equal to 0. So look at this. So I took n vectors and I'm not worried about the dimension of the vector, but all of them are supposed to be of the same dimension. So I took n vectors and I'm writing as if they are connected. But take a look at this. I put lambda 1, lambda 2, lambda 3, lambda n, that is n scalar quantities like numbers. For example, I'll show you two variables x and y. Let's suppose they are connected linearly. That means there will be some sort of relation between them. I hope you got the point. If they are connected linearly, then there should be some sort of connection between them. So look at this. X and y are connected by the relation 3 into x minus 2 into y equal to 0. If they are not connected linearly, then that means there is no connection between them. That might put you in confusion. Or let's say there will be no relation as such. Okay, now I'll come back to the point. Suppose this lambda 1, lambda 2, lambda 3, etc., lambda n, or a few of them are non-zero numbers. Then that means there is a connection between them. But if all these lambdas, lambda 1, lambda 2, lambda 3, all of them are equal to 0, that means we get 0 equal to 0, there is no connection. Okay, now let's try one example so that you understand the concept properly. Okay, the question goes like this. Are the following vectors x1, x2, x3 linearly dependent or independent, where x1, x2 and x3 are given by, okay, so please note down the three vectors. So look at this. We are given three vectors, and of course they are vectors in 3 dimensions. If you want, you can read like I plus 2j plus 2k, 2i plus j minus 2k. But here we don't care about the dimension. Sometimes it will be in 2 dimensions, sometimes 3 dimensions, sometimes more than 3 dimensions. So we don't care about that dimension part. Anyway, what I do is I will assume let lambda 1 x1 plus lambda 2 x2 plus lambda 3 x3 is equal to 0, where lambda 1, lambda 2, lambda 3 are scalars which are to be determined. We don't know about those values, but we are trying to determine them. And then I will substitute the values, and it is better if you write the vectors like this. It will be easy for you to simplify. So lambda 1 into 1, 2, 2 plus lambda 2 into 2, 1 minus 2 plus lambda 3 into 2 minus 2, 1 is equal to, I'll take the 0 vector to be of the same dimension, 0, 0, 0. Okay, and this is going to give me 3 equations. So I'll read the first equation. Look at this. I'm going to multiply this vector by lambda 1 and this vector by lambda 2 and the third one by lambda 3 and add them up. So the first equation will be lambda 1 plus 2 lambda 2 plus 2 lambda 3 is equal to 0. And the second vector will be 2 lambda 1 plus lambda 2 minus 2 lambda 3 is equal to 0. And the third vector 2 lambda 1 minus 2 lambda 2 plus lambda 3 is equal to 0. Okay, in the last video we learned about homogeneous equations. And take a look at this. Aren't they homogeneous equations? Okay. And I'm sure that you know how to solve homogeneous equations. So let's start. So let A equal to 1, 2, 2, then 2, 1, minus 2, and 2, minus 2, 1. Now, how do you solve a homogeneous system? Very simple. Find the rank of A, compare with the number of unknowns. The number of unknowns is equal to 3 because there are 3 unknowns, lambda 1, lambda 2 and lambda 3. Okay, so I'll write the matrix operation, and I'm sure you're finding this operations very easy now. So the first one is R2 changes to R2 minus 2 R1 and R3 changes to R3 minus 2 R1. Okay, so there'll be no change in the first row, that is 1, 2, 2, and the second row will change because these are my targets, 2 and 2. So it's going to be 0 and 1 minus 4, that will be minus 3, minus 2 minus 4, that gives me minus 6. Again 0 and minus 2 minus 4, that will be minus 6, and 1 minus 4, that will be minus 3. Okay, so this is equivalent to. Now what should I do next? I move to the second row and find the first non-zero element, and I had to convert that non-zero element into 1. So the operation is R2 changes to R2 into 1 by minus 3. So 1, 2, 2, 0, 1, 2 and 0, minus 6, minus 3. Okay, now we have 1 and all the elements beneath 1 are equal to 0. Then I move to the second row. The first element or the first non-zero element is already 1. So my job is to make the element beneath that 1 into 0. So I'm going to write the operation. My target is in the third row. So R3 changes to R3 plus 6 R2. So there will be no change in the first row, and the second row remains the same, and the third row 0, minus 6 plus 6 will be 0, and minus 3 plus 6 times 2, it will be 12, 12 minus 3, 9. And we are almost at the end. So we have 1, all the members beneath that 1 are zeros. Now the second row, the first non-zero element is 1, all the elements beneath are 0. The third row, the first non-zero element is 9. So I'm going to write R3 changes to R3 into 1 by 9. If you want, you can skip this step, but it is better that you do this step because you'll get the proper echelon form. Okay, that's it. So rank of A is equal to 1, 2, 3. There are 3 non-zero rows, and that will be equal to the number of unknowns. Now, what does this imply? This implies our system has unique solution. But in the case of a homogeneous system, unique solution implies all the answers will be equal to 0. So that means lambda 1 equal to lambda 2 equal to lambda 3 is equal to 0. And what does it mean? In the beginning, we assumed that let there be a relation in the format lambda 1 x1 plus lambda 2 x2 plus lambda 3 x3 equal to 0. But just now we proved that lambda 1, lambda 2 and lambda 3 are zeros. So that means there is no linear relation between the vectors. That means the given vectors are linearly independent. So if you are confused, I'll repeat once more. In every question, they will give us a few vectors. So what do you do first is, you just write, if possible, let lambda 1 x1 plus lambda 2 x2 plus lambda 3 x3 plus, okay, as many as there are vectors is equal to 0. So write if possible and you can give it equation number 1. Now you substitute the vectors, and for simplification purpose it's better to write as a column, and you will get 2 or maybe 3 or maybe 4 equations or maybe more, okay. And I can guarantee you one thing, the system will be homogeneous, because we are equating it to 0, you're going to get a homogeneous system. And in the last video we learned how to solve homogeneous system. So we find the coefficient matrix and then we find the rank of the coefficient matrix. So it may be equal to the number of unknowns or it may be less than the number of unknowns. If it is equal to the number of unknowns, then all the lambdas are identically equal to 0. That means lambda 1, lambda 2, every lambdas will be 0. And that implies linear independence, because lambda 1, lambda 2, lambda 3 is equal to 0 implies such a relation does not exist. And if the rank of A is less than n, that means a few or all the lambdas are not equal to 0. And which implies they are dependent, because there is some sort of connection between the vectors. Anyway, let's make the concept more clear. So write one more question. Check whether the following vectors x1, x2, x3 are linearly independent or dependent. And if they are dependent, find the relation. I'll read it once more. Are the following vectors x1, x2 and x3 dependent or independent? And if they are dependent, find the relation between the vectors. And the vectors are given by, okay, so I hope you have noted the question. So shall we start? Okay, as I told you before, whenever you get a question related to linearly independence or dependence of vector, the first thing to do is you to write, if possible, let lambda 1 x1 plus lambda 2 x2 plus lambda 3 x3, and that's the last, is equal to 0. Call it equation number 1. And then you can write, that is lambda 1 into, I'll strongly recommend you write it column wise. So 1, 2, minus 3, 4 plus lambda 2 times 3 minus 1, 2, 1 plus lambda 3 times 1 minus 5, 8 minus 7 is equal to the 0 vector of the same dimension. And that gives me 4 equations. So that will be lambda 1 plus 3 lambda 2 plus lambda 3 is equal to 0, 2 lambda 1 minus lambda 2 minus 5 lambda 3 is equal to 0, minus 3 lambda 1 plus 2 lambda 2 plus 8 lambda 3 equal to 0, and finally 4 lambda 1 plus lambda 2 minus 7 lambda 3 is equal to 0. You end up with a homogeneous system of equations. And you know how to solve a homogeneous system. So the first thing to do, you write the coefficient matrix. And that will be 1, 3, 1, 2, minus 1, minus 5, minus 3, 2, 8, and 4, 1, minus 7. Now let's find the rank of this matrix. So the first element is 1, that is good news, and our targets are 2, minus 3, 4. And I'm sure that you're experts in writing the operations. R2 changes to R2 minus 2R1, R3 changes to R3 plus 3R1, R4 changes to R4 minus 4R1. And that will be 1, 3, 1. Of course, 0. Now, minus 1, minus 6. Minus 5, minus 2. Of course, 0. So, 2 plus 9. 8 plus 3. And 0. 1 minus 12 and minus 7 minus 4. Okay, that's good. So the first element is 1, and we just converted all the elements beneath that 1 to 0. Now my job is I move to the second row to the first non-zero element, and I have to make it 1. And the operation goes like this. R2 changes to R2 into 1 by minus 7. 0, 1, 1, 0, 11, 11, and 0, minus 11, minus 11. And the next step is to make all the elements beneath this 1 into zeros. And that's going to be really easy. So I'll write the operation R3 because my target is in R3 and R4. So R3 changes to R3 minus 11 R2, and R4 changes to R4 plus 11 R2. And I'm sure that you know what's going to happen. It will be 0, 1, 1, and of course 0, 0, 0, 0, 0. So we end up in that echelon format. I think you can see that echelon clearly here. Look at this. Rank of A is equal to 2, but number of unknowns is equal to 3. So rank is less than number of unknowns. That means we will have infinite number of solutions. And n equal to 3, the common rank or the rank is equal to 2. So n minus r is equal to 3 minus 2 is equal to 1. That means one unknown can be given any value you like. So let's write the equation. Lambda 1 plus 3 lambda 2 plus lambda 3 equal to 0, and lambda 2 plus lambda 3 equal to 0, and no more equations. So I'm going to set lambda 3 equal to k, because I already told you one unknown can be taken as any arbitrary constant, and using this value over here I get lambda 2 equal to minus k. And using these two values in the first equation, we will get lambda 1 minus 3k plus k equal to 0. So lambda 1 will be 2k. So substituting all the lambda values in equation number 1, I hope you still remember equation number 1. So what we do is lambda 1 is 2k, so I'm going to put 2k into x1 minus k times x2 and lambda 3, that is k times x3 is equal to 0. Now k is common and k is non-zero, so the relation is 2x1 minus x2 plus x3 is equal to 0. So look at this. That means the vectors are linearly dependent, and this is the connection between them. Because if the vectors are dependent, then there will be a connection between them, and this is how the vectors are connected. So I'll stop this video over here. In the next video, we'll be doing something extra important: mark point of view and subject point of view, and that will be the characteristic equation, and we'll be moving on to matrix transformations. So till then, bye. And if you like this video, please like, share and subscribe.